Welcome to solverfy.
We've got several molecules that we need to determine if they're capable of showing cis-trans isomerism. And I think what's really nice to do in problems like this is to just simply observe if we can notice right away any internal mirror planes, because as we know, mirror planes will negate any chance of the molecule having stereocenters or showing cis-trans isomerism in the case of ring structures, which are not stereoisomers, but rather cis-trans isomers. And so this is the 3D sort of bond line representation we've been shown. But what could be useful is to redraw as a top-down view. For example, something like this, right? And recall that in actual fact, if we were looking at this top-down, that if, say, this were red and this were green, that in fact those two groups would be overlapping each other and not offset in the way they are. And that's important because when we realize that's the case, then we can immediately see a mirror plane in the molecule. If we slice it in half lengthwise, the left half and the right half are perfect mirror images of each other, which means that I cannot show cis-trans isomerism. So let's continue now. We've got 3D representation of dimethyl 1,2-dimethyl cyclohexane. And this view right here is actually not too bad because from this view, we can immediately recognize a mirror plane, right? The left and the right half are indistinguishable from each other about this plane that we've bisected the molecule with, which means the answer to 2 is also not possible. Let's look at number 3. We've got a methyl group over here and an ethyl group over here. And so it may be kind of simple to see that we can't simply draw a line down the middle. That would not create a mirror plane. Something else we could do is we could find the S or R designation of either the stereocenters, which could reveal to us that there's no cis-trans isomerism possible, or we could draw it top down, which may also aid in our ability to see that if we have a methyl coming towards us here and an ethyl coming towards us here, that the only real logical mirror plane you can draw for a 5-member ring is bisecting one of the carbon-carbon bonds and one of the carbons itself. But since we have a methyl group on the left and an ethyl group on the right, these are not mirror images of each other across this line. So there's no internal plane of symmetry, which means that we can say that number 3 is capable of displaying cis-trans isomerism. Now on to number 4. Substituted with an ethyl group and an ethyl group. But note that we've got a hydrogen above in this case and a hydrogen below in this case. And here's where a top-down view might come in handy. This is a 1, 2, 3, 4-membered ring. And that on neighboring carbons, we have an ethyl group down below. And neighboring it, we have an ethyl group up above. So does this have a mirror plane of symmetry? Well, again, the obvious ways of bisecting a square would be either diagonally, which we know won't work because if we look from this corner to this corner, there's not a matching ethyl group, or through the carbon-carbon bonds themselves. And again, we can say, okay, we've got a wedge to ethyl over here, And if we reflect across the line, we have a dashed ethyl where we should have a wedge if there were an internal mirror plane of symmetry. So this has no internal mirror plane of symmetry, which means it is possible to have cis-trans isomerism. Okay, final one. Another four-membered ring. I should draw it in the four-membered form. And we've got a 3-carbon chain coming off of the end. So that's butyl propyl cyclobutane. And again, I think a top-down view will help here. And we know that we have a dash to a 3-carbon chain. That's 1 carbon, 2 carbon, 3 carbon. And suddenly we notice that we can split this diagonally and that everything will reflect across. Don't get fooled by this chain, because we can rotate the chain about the single bonds however necessary to get it to lie along this flat or lie along our bisecting line. The other way to think about it is that this chain is really irrelevant in terms of its ability to lie across the mirror plane. So we could simply say N-butyl, or N-propyl rather. And then we can see much more easily that there is an internal mirror plane of symmetry, which means the answer to 5 is no, not possible.